I'd like to move straight on to our second speaker for this evening, which is Professor Les Underhill. Les, I'm sure, is known to all of us. Les, who used to be the director of the Animal Demography Unit, and since his retirement has been instrumental in establishing the Biodiversity and Development Institute. And one of the key programs of this institute, which Les heads up, is the Virtual Museum projects. And Les is going to share with us this evening what went well for the VM projects last year in 2020, and how we can improve on this in 2021. Les, thank you very much. And I think it's only apt that our first webinar of the new year is dedicated to partly looking at the Virtual Museum achievements of 2020 and plans for 2021. So over to you. Thank you, Les.
Thanks, thanks, Rick. Has that set up properly on your screens?
That looks perfect.
Okay. So how do I get it to move on? Okay, yes. So in 2020, in spite of all the challenges and keeping indoors and all the rest of it, 24% up on total number of records. Four sections, 4 projects within the Virtual Museum had their best years ever. Odonata map, which had been doing remarkably well for a whole bunch of years, actually has struggled through the drought at the end of last year. And Lepi map, even though it was up on last year, most of that upness was in the first part of the year, and not towards the end. So insects, in broad brush terms, had a rough start to the summer in the south last year. But the guts of what I want to talk about tonight is how do we measure how well we are doing. So my background is statistics primarily, and so I have to think about these sorts of things. So for years and years and years, we've thought about once we've got a record of a species in a grid cell, we've kind of got it. So we don't need to bother about recording it again. But for some projects, and particularly the ones like reptile map, Lepi map, the data sets are getting a bit long in the tooth, and they really need to be refreshed. So if we were asked to do a map using just say only the past 5 years of data, there'd be lots of old records which would need to be excluded, for which there isn't an up-to-date record of the species. So there'd be lots of gaps in say 5-year maps produced now of data from the past 5 years. So we need to have some way of measuring how well we are doing in terms of up-to-dateness, and that's the challenge for me as statistician, is to devise something which is both meaningful in terms of it measures what it's supposed to be measuring, and which is transparent, something which is not just a big black box. And you, the people who have to judge whether what I've come up with is actually achieves that. So this is my new management table for the projects. I've just put 3 projects in here, and I'll unpack all those numbers a little bit later on. And the way I've set this up here is there are 3 lines for each project. And the first line has got all the data up to the end of 2019. And the second line has got the observations that were made in 2020 only. And the third line for each project has the data up to the end of last year. So there's a a column called grid cells, and what that gives you is the count of the number of grid cells for which there is data. So there are 1,974 quarter-degree grid cells in South Africa. So that's the number to put into the denominator to get a percentage. Species is the number of species that have been recorded over the time period in the data set. And then there's this column which is headed grid cell species, and that's maybe a tricky concept. So if one grid cell has 14 species, another one has 10, and a third one has 12, you add those together, and I hope I've done the arithmetic right and got to 36. So in this context, records is just those from South Africa which have been identified to a species level, or in the case of LepiMap, sometimes subspecies level. And the median date is this new measure of how old the data is, how long in the tooth it is. So there are 4 steps to finding this number. So for an individual grid cell, you take the list of species, you calculate the most recent date on which the species has been recorded. Calculate is a bit stronger word. You just find the most recent date for each species. You sort all these dates and you find the date in the middle. And that's the date the statistician calls the median. So that's the age of the data for the grid cell. So I use the median and not the mean, because when you have some vagrant and it only occurs once, then it will drag the mean backwards. So the median is what a statistician calls a robust measure of the center of the data. It's not influenced by outliers. So you find the age of the data for each grid cell defined in this way. And then you do this for all the grid cells in South Africa. So you find the median date for all these grid cells. And then you sort this second set of data and you find the date in the middle once again, the median. And this is the age of the data set, in this case, BirdPix, that we are looking at. And the drive is to keep this date as recent as possible. So we want the average age of the data to be new, and we want to move this date forward by 1 year each year, so the data doesn't get progressively more and more out of date. And it turns out that, gosh, this is a tough measure, because firstly, it needs us to visit lots of grid cells, because we have to move all these dates forward, and it needs a lot of effort in every grid cell we visit. So this is the strategy. This is how we measure how well we are doing in terms of keeping the data up to date. And the hack, the trick for actually moving these dates forward is to do the one thing which we've tended not to do. We've tended to ignore the common species. So we must, if we want to move the dates forward, the trick is to move the, is to refresh the records of the most recent species. So this is this table again, and the next 3 slides go through each of these projects and tries to unpack all these reams of numbers. So Oceanata Map, it started in 2011. Rene Navarro started it, and it just kept pottering along for the first few years. But all of a sudden, since 2017, thousands of, or 10,000 at least, records per year. So 72% of the data is subsequent to 1 January 2017. And this analysis that I'm doing includes also the ADO data, the Odonata database for Africa, which KD set up. So, and that's a database of historical records, museum records, records made by academics. So it's a huge boost to the data set. So what the column-headed grid cells does is it tells us that up to 2019 there was 1,098 grid cells with data. In next row, in 2020 we visited 397 grid cells for Odonata map, and not all of those grid cells were new. So the number of grid cells now is 1126. So some grid cells were visited all over again, or repeat visits. There are 164 species in Warwick Tarleton's book. Some of them are have only been recorded once or twice. So the fact that the total number of species seen at the end of 2020 is 163 is amazing. We saw 149 of these in 2020, and that is a remarkable achievement by Team Odonata map. The number of records identified to species in 2020, second last column, middle number, 15,412. The Odonata are quite difficult in that many of them just cannot be identified to species. So these are the species record. And so we made the map out of 2020 records over the number in the fourth column tells us that 3751 grid cells would be shaded. So that's not an awful lot. So the complete set of grid cells at the end of 2020, 15701, 16583. So that's an increase of 882. So in other words, there were 882 first records of species in grid cell. And the median date improved by 10 months in 2020, which we would like to have been 12 months. So so we actually went backwards by 2 months. Now we tackle BirdPix. So BirdPix is particularly important in this context. It is, in a sense, a duplication of SABAP2, but what we are using this data for is to try and build species distribution models, not unlike the models that Melissa was talking about, and try and replicate the bird atlas maps. And if we can do it for BirdPix, then we can hopefully do it for the butterflies, the scorpions, and everything else, for which it is impossible to do an atlas project in the way that bird atlas projects are done, making comprehensive lists of species. So BirdPix is a new project. 78% of the records are 1 January 2017 onwards. No historical database going with it. So the number of grid cells at the end of 2019, 1347, increasing to 1407. So we only added 60 grid cells to the number which were included, even though we did 686 grid cells in 2020. Roughly 950 species, lots of vagrants. We saw 669 species in 2020, and we increased the number of species which we have data from 817 to 830. And over on the right, the median date. So even with this huge amount of data, 31,000 records in 2020, we shifted the median date ahead by 11 months. So we didn't actually move it ahead by a year. So this measure that I've set up for measuring the up-to-dateness of the data, it's a really, really tough measure. and it's not easy to actually move things along by a whole year, every year, even with this amount of data. So reptile map is a very gentle continuation of the reptile atlas project called SARCA, and SARCA computerized all the reptile records it could get hold of, right from the beginning of museum collection records. Every bit of data that we could get hold of, we included. The coverage was amazing. So at the start of 2020, end of 2019, 1,815 grid cells out of the 1,900 odd had records. So, so remarkable coverage. So just really not an awful lot of data in 2020. 2,231 records were ID'd in South Africa to species, and so it's quite modest totals. The number of grid cells visited, 421. The number of new grid cells, amazingly, 5 grid cells which didn't have data before now have data. And but the horrifying thing is the median date. So the median date in end of 2019 was in 1962, and there couldn't have been very much data through the 1960s. So the end of 2020, it calculates up 5 years later, but that's still 50 years ago. So so the reptile map database is getting really quite long in the tooth. So when we produce distribution maps out of that database, we cannot really anymore claim that they are up to date. But there isn't a dedicated reptile atlas project on the go. That's something which we need to work on. So these are 3 projects which I chose because each one is quite different, and they have different needs. So when you ask me what does all this mean, first of all, the answer is it's hard to say. It's hard to say largely because we can't really compare these projects. It's chalk and cheese. Each one is different. Each one has different needs, different points along its development. So we can't compare projects and say, oh, reptile map is doing badly, but each one has got its own thing. The other reason why it's hard to say anything is because one actually needs several years of data to trace patterns. But for me, the astonishing thing is how much we have achieved with a minimal amount of coordination in terms of keeping the data up to date. So now that we've got an algorithm to measure how well we are doing, we can present results at quarterly intervals, say, and then we can actually plan how to fill the gaps. And if anybody would like to actually help play a role in this, I would very happily accept that help. So we haven't talked about LepiMap at all. So so this is the kind of map that you need for doing your planning. So this is the LepiMap data in Limpopo up to the end of 2019. Those were the grid cells that had data, 214 of them. Almost every data has got grid cells. So this is butterflies and moths, and it's a big database and very impressive. So 14th of March 2009 is the median age, and you see in the next slide how that has changed. So that's a key number to look at. 2009, so this data is 10 years old, 11 years old now. So it's starting to really need to be refreshed, and it's gone from the 14th of March 2009 to the 5th of May 2009 as the median age. It hasn't really, on a provincial level, actually moved forward a huge amount. So this is the data which was actually collected in Limpopo during 2020. You can see there's a few hotspots where there's a lot of species being recorded. So the numbers in the grid cell are not number of records, but number of species. Going on to bird pics in KwaZulu-Natal, just choosing a few provinces at random. Up to December 2019, quite remarkable coverage. And here we go for 2020. And if you go backwards and forwards, you can see quite a few grid cells have improvements, quite a few stay the same, and there's 154 grid cells at the end of 2019 and 156 a year later. So we haven't filled many of the gaps in terms of actual grid cells. So this is the 2020 data, just 87 grid cells, and the reaction I get when I show this to people is why didn't you show us these maps during the year when we could have done something about the gaps? And that's what we are planning to do this year. So here is the map for bird pics today for 2021 data, and these are the maps that if we could make them available to people, these are the maps that can be used to actually plan where you're going to go to in 2021. Here's the same thing for the dragonflies and damselflies. This map was made yesterday, and if you count the grid cells, there are 20. I compiled the data on the left this afternoon, and between yesterday and today, the number of grid cells has increased from 20 to 27. So so these things are really moving, but there's a real need to get out into the northwestern part of KwaZulu-Natal and fill in the gaps there. So I focused on South Africa, but the reality is that the parish of the virtual museum is Africa as a whole, and this is the coverage map for bird pics in Nigeria. 1,306 quarter-degree grid cells, 161 have data. So for on an African scale, bird pics can actually make a huge contribution to the African Bird Atlas project, because it provides an opportunity for people who don't have confidence in their identification skills to actually make a contribution. So the bird pics data in Nigeria, median date 12 October 2019. So that is remarkably up to date. So my final slide is to thank Chorus for constructing the maps. I thank you very much indeed. Some of them were made quite late this afternoon. Thank you, Chorus. The whole team Virtual Museum, amazing support through the years, and especially through 2020, which was a tough year in many ways. So we have a New Year's resolution for Team Virtual Museum. It runs like this. Starting in our home grid cells, we will upload records for as many species as possible, and the hack to keep things up to date. Be especially careful not to neglect the common species. Wherever we travel in Africa in 2021, we'll do our best to keep the distribution maps up to date for as many species as possible. And I remind you that if you'd like to help with the coordination of the project in a country or a province, then please just send me an email. Thanks very much. Thank you.
Thank you, Les, for a thanks, Les, for a very comprehensive look into the achievements of 2020, and also for setting us those quite incredible goals for 2021 and onwards. And thanks very much for helping us with those three examples, those three VM projects, helping us to see how this all comes together, and of what use the data that we as citizen scientists are collecting, of what use that data is to statisticians like yourself, to make sure that we are getting the absolute most out of all of the effort that's going into these virtual museum projects that we, I'm sure, all enjoy very much contributing towards. Otherwise we wouldn't be on this forum, I'm sure. So I think on behalf of us all, thanks, Les, for putting that into perspective for us, and we look forward to seeing updates as we go. And I think there's some very good and concrete objectives for us there to try and keep the projects going and to keep them refreshed, keep the records refreshed, and keep them as up to date as possible. I just have there's a question from Mark Heremans, and he just says, to move the median date each year forward by 12 months, would that not require an ever increasing number of records each year?
Mark, I haven't thought my way through the statistics of it all that carefully, but gosh, I was horrified that all that effort we put into BirdPix last year, we only moved it forward 11 months. Of course, we lost a couple of months in the lockdown. So we'll need to see what we can do this year, and also the idea of actually keeping the common species recorded, and let's try and do it on an annual basis. And we need to, I think, do some experiments as to what time period maps make sense. So how old does a record need to be before it's no longer decent evidence that a species occurs there? So a secretary bird record from 2000 is not good evidence that the species still occurs in that grid cell. So and that applies to butterflies and reptiles as well. So those are questions which I don't think any of these biodiversity projects have really seriously looked at. Is how do records decrease in value as evidence? And that's I think it's quite a nice topic for someone to tackle.
Thanks, Les, and Mark, thanks for your question. I think I'm just having a look at the comments and a few questions as they come up, and what's quite clear is that all of us are very grateful, Les, to you for for giving us this presentation, for championing the challenges for the new year. I think that's something that you do very well, and please keep doing that. I think that we all need it. Melissa, maybe working on projects such as the Secretary Bird project, which is a very specific project, that maybe the kind of question that Les is posing could be something that could possibly be looked at. And again, as Melissa has commented, as she has thanked the dedicated army of citizen scientists, saying that without the efforts of the citizen scientists, the work of scientists and conservationists would not be possible. And I think we're all very aware of that. But perhaps there's a good opportunity for even more synergy here, where those of you involved in the conservation of our bird species, such as the secretary bird, can look at it scientifically and get back to us and say, records that are this old are the ones that really count, or this young. They need to be this young for them to really count. Taking the biology and the ecology of the particular species and all its challenges into consideration. So I think that, there's just much appreciation coming through in the comments. Mark also made the comment that environmental changes are so fast these days, and he proposes records older than records of presence older than 5 years may in fact be outdated, and I think there's probably a lot of truth in that. Steve Woodall, just makes the comment that it would be good to share these stats with our members, and Steve, you're referring to LEPSOC members, in 2021, and LEPI map as well. Get them fired up to push out these median dates. I think that I think the challenge is out there. We, as citizen scientists, we all know what we're needing to be doing for the new year. Mark does also mention that old records obviously are very important for doing the comparison and updating our red lists, our red data lists, seeing what the situation was and what it is now. Those older records are very, very important indeed.
Sorry, yes, can I just say in support of Mark, and if we can produce a map from 2010 to 2015, a good quality map, and then we can produce another good quality map 2016 to 2020, then we get a really good idea of what has changed, and we can measure in some sense the volumes of data and compare the sort of standardize the effort between maps. We just don't have to take the maps at face value, but those are very powerful tools to get across the message of shrinking ranges, and so we're not only so we think of the virtual museum going back into the age of digital cameras about soon after 2000. If you've got any data from even yonks ago, please upload it, because it's all part of that important historical record to see where things were in the old days. Thanks, Rick.
Thanks very much. And to coin the phrase,